Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Welcome to my YouTube channel Learn with Azam. Today we will start the new syllabus with Punjab Book Foundation Physics SSC-II Unit number 15. Electromagnetism. Today we will solve according to SLO base or FBISC requirement numerical problems question number 1 to 5. In this chapter total numerical of exercise 1 to 5 and remaining we can solve the conceptual and other in next video. Subscribe our channel. Best of luck. Now we will start the today lesson. Question number 1. Numerical problems. Question number 1. Given statement. A transformer is needed to convert a mains of 240 volt supply into a 12 volt supply. If there are 200 turns on the primary coil, then find the number of turns on the secondary coil. Now, according to the given data, first of all, we write the given data. Now, in given data, Vp voltage of primary that is equal to 240 volt and Vs voltage of secondary coil that is equal to 12 volt and number of primary turns that is equal to Np is equal to 2000. Now we can calculate or find that Ns number of turns on secondary. So according to the formula, number of secondary coil divided by number of primary coil that is equal to Vs voltage of secondary coil divided by voltage of primary coil. Now we can calculate number of turns on secondary coil, so we can find the solution. As we know that number of secondary coils that is equal to voltage of secondary coil divided by voltage of primary coil multiplied by number of turns of primary coil. Now we can find the answer then putting the values. Ns is equal to 12 divided by 240 multiplied by 2000. Here 12 divided by 240 that is equal to 20. So 2000 divided by 20 it will be equal to 100. So the number of turns on secondary coil, the final answer is 100 turns. So given result of the number of turns on secondary coil Ns is equal to 100. Now we will move the numerical problems. Question number 2. In question number 2, given statement, a step-up transformer has a turn ratio of 100:1. An alternating supply of 20 volt is connecting across the primary coil. What is the secondary voltage? Now we can find the secondary voltage. According to the given statement, we can write the given data. In given data, Vp voltage on primary coil that is equal to 20 volt. So ratio of Ns over Np number of turns on secondary coil divided by number of turns on primary coil because this ratio is a step up transformer that is equal to 100 divided by 1. Now we can require that voltage of secondary coil. Now we can use the formula. So Ns over Np that is equal to Vs over Vp. So in our solution we can know that according to the formula number of secondary coil divided by number of turns of primary coil is equal to voltage of secondary coil divided by voltage of primary coil. Here this value is divided, it will be multiplied on other side. So we arrange the formula. We have putting the values. The ratio of NS over NP is equal to 100 divided by 1, that is equal to Vs divided by 20. 20 is multiplied on other side, so this implies that Vs voltage on secondary coil is equal to 100 multiplied by 20. 100 multiplied by 20, so the voltage on secondary coil that will be equal to 2000 volt. So the resultant of this answer, voltage on secondary coil that is equal to 2000 volt. Now let's start the numerical problem. In numerical problem question number 3. A step-up transformer has a turn ratio 1:100 and AC voltage of amplitude is 170 volt is applied to the primary. So the current in the primary is 1 milliampere. What is the current in a secondary coil? Here we can find the current in secondary. So, according to the statement, write the given data. Voltage on primary coil Vp is equal to 170 volt and ratio of Ns over Np, because given transformer is step down transformer, so we write Ns over Np is equal to 1 divided by 100. Here Ns is the number of turns on secondary coil divided by number of turns on primary coil is equal to 1 divided by 100, and current on primary IP is equal to 1 milliampere. Here milli is equal to 10 raised to power minus 3. So IP is equal to 10 raised to power minus 3 ampere. Now we can require that IS, current on secondary. So we using the formula according to given condition. Formula is Ns over Np is equal to Vs over Vp. We know that power on primary that is equal to power on secondary. So we also write that IS over IP is equal to VP over VS. Now we using the formula and find the solution. As we know that Vs is equal to Ns over Np into multiply by Vp. Here putting the values, Ns over Np ratio is equal to 1 over 100. So Vp value is 170. Here 1 divided by 100 multiply by 170, that is equal to 1.7 volt. Now we can find the current for the ideal transformer. Power on primary that is equal to power of secondary. So we can write that IS over IP is equal to VP over VS. That is equal to putting the values, then IS over upon 1 multiplied by 10 raised to power minus 3 is equal to 170 divided by 1.7. Now we can calculate the value, then IS, current on secondary, that will be equal to 0.1 ampere. Now we will move the next numerical problem, question number 4. In question number 4, given statement, a transformer designed to convert the voltage of 240 volt AC means to 12 volt, has 4,000 turns on primary coil. How many should be the secondary coil? If the transformer were 100% efficient, what current would be followed through the primary coil when the current in a secondary coil is 0.4 ampere? So, first of all, according to the given statement, we write the given data. In given data, we can have given data Vp, voltage on primary, that is equal to 240 volt, and number of turns on primary, that is equal to 4,000 turns. Similarly, we have voltage on secondary, that is equal to 12 volt, and also given that the current on secondary, that is equal to 0.4 ampere. Now we have required that number of turns on secondary and also in B part current on primary coil. So we using the formula and calculate these values. First of all, write the formula. NS our NP is equal to Vs our Vp, and for an ideal transformer, this condition is always satisfied. Power on primary, that is equal to power on secondary. So we apply the formula IS our IP is equal to VP our VS. Now we can solve the solution and write the first part. In first part, we can calculate NS, number of turns on secondary coil. So we arrange the formula NS is equal to Vs over Vp into multiply by Np. So putting the values 12 divided by 240, then 12 divided by 240, that is equal to 20. Here 1 upon 20 multiplied by 4,000. This means that 4,000 divided by 20, that is equal to 200. So the number of turns on secondary coil, that is equal to 200. Now in B part, for the ideal transformer, IS is equal to Vp over Vs into Ip. Here we rearrange the formula, then Is current on secondary, that is equal to voltage on primary divided by voltage on secondary, also multiply by current in our primary. So putting the values and find the solution, that will be equal to 0.02 ampere. For our result of this question, for our first part A part number of turns on secondary, that is equal to 200, and current on secondary, that is equal to 0.02 ampere. Now we can calculate the values. Numerical problem question number 5. A power station generates the 500 megawatt of electric power, which is to feed the transmission lines. What current would be flow in the transmission line if the input voltage is 250 kilovolt? Here, first of all, write the given data. In given data, V is equal to 250 kilowatt. Here, 1 kilo is equal to 10 raised to power 3. So, 250 multiplied by 10 raised to power 3 volt. And power P is equal to 500 megawatt. And 1 mega is equal to 10 raised to power 6. So, power P is equal to 500 multiplied by 10 raised to power 6 watt. Now required that the current I. In current I, first of all, write the formula. For formula P is equal to VI. Then we use the solution as we know that I is equal to P upon V. Then putting the values I is equal to 500 multiplied by 10 raised to power 6 divided by 250 multiplied by 10 raised to power 3. The final answer is 2000 ampere. So the resultant of numerical problem is I is equal to 2000 ampere. Best of luck. Subscribe our channel. Take care.